Hello, I'd like to go over some fluvial or river processes and how those help shape the landscapes that we see around streams and rivers. First important concept to keep in mind is that moving water has energy, and that energy picks up sediment, which are small pieces of material, small particles of rock or dirt. And so that sediment is picked up, and we call that erosion. So the water erodes, and the sediment then is transported by the water. And we see here three basic categories of sediment, depending on the size of the sediment. The bottom one, or the bigger particles, are called bed load. They travel along the bottom of the stream, and they're basically, we have they're either being dragged, that's traction, or jumping on the bottom, that's saltation. The other two loads or sediment loads are suspended load, which are very tiny particles. You can kind of almost see them here in this picture. They very tiny particles that are not big enough to sink to the bottom, but they basically float on the water. When you see a river that looks brown, what you're seeing is a suspended load, because that would make the water look turbid or not clear. And then finally we have the dissolved load, and that is chemically dissolved, meaning minerals. Maybe think, if you add salt to water, the salt just kind of disappears, but it's still there because basically the salt has dissolved or chemically become part of the water. Okay. So those are the three basic types of sediment that streams and rivers carry with them, that they have eroded away. However, when the river slows down, it will lose energy and release this sediment. Okay, let's talk about floodplains. A floodplain is an area where that a river regularly floods. Usually this would be a fairly flat area with a river that is a higher order river, one that's flowing relatively slowly and has begun to meander. Meander means it's going back and forth in these snake-like loops. Okay, and rivers that are flowing slowly tend to do that. That are flowing on a fairly flat area. So the river will flood occasionally, because the supply of water, during springtime or in places where there's no melt off, additional water comes down, and the river may overflow its banks and cover the area that we call the floodplain. The water that is flooding has sediment, and once it overflows the banks, the water slows down and releases its sediment. So the floodplain regularly gets a new layer of sediment that we call alluvium. Right? The sediment that is deposited by flowing streams is alluvium that is deposited on the flood bank. And this is one of the reasons that floodplain areas are good agricultural areas. Here in this picture we can see all the fields, because the sediment or alluvium that is deposited has, we talked about dissolved load, has minerals, and the suspended load also has nutrients that plants need. And so floodplains tend to be great places, some of the most fertile land to grow crops. They may not be the best places to live because you can get flooded. Okay, so let's take a closer look at a meandering river Here we have a meandering river going around this way, and basically here we see the two main processes of erosion and deposition helping shape what is happening here. Rivers that meander. At each turn, we have what are called an outer bank and an inner bank. So the outer bank is an area where the river flows faster, and because of that, it has more erosive power and it erodes the outer bank. So we call it the cut bank that is being eroded. So this bank of the river is being eroded and moving in that direction. On the other hand, in the inside of the loop or the curve, we have what we call a point bar. A point bar is an area where sediment is being deposited because the river is flowing more slowly in the inside of the curve. So it deposits sediment. So this starts growing. Aggradation is the term that we use. It's getting bigger because sediment is being deposited, and so it starts traveling in that direction. Okay, so the whole thing is very dynamic. It's always moving. The point bars are growing in one direction and the cut banks are being eroded in another. Notice this little house here is probably not the best place to build your house as for obvious reasons. So here we have a picture of that house again. So let's say this is your house and this is your room and you're sleeping. Well, suddenly you might find yourself waking up and you're floating on the river. Probably not the best morning wake up routine. Okay, so here is we'll talk about what an oxbow lake is and how it is formed. Here we have the meandering river again. As I said, the outer banks get eroded, the inner banks they get built up or go through aggradation. They grow. But here we're going to focus on the erosion going on in this outer bank and this outer bank. So they are moving because they're being eroded. They're moving. This one's moving this way. This one's moving that way. Okay, so as they start moving towards one another, as they're both eroding, they're both outer banks, they're both eroding and they start moving towards one another and forming a neck. So this is getting narrower and narrower, and eventually the river just cuts through. Okay, at that point, this meander is no longer it no longer has a current. It no longer has flowing water. It's standing water, and it begins to become isolated because now the river is flowing, has taken a shortcut in a way. Okay, so as that happens, then the connection with the river just gets plugged up with silt and clay. And now we have what we call an oxbow lake. So an oxbow lake is a lake that used to be a meander, so it's kind of an odd shape lake. It's shaped like a horseshoe. And as it happens to all lakes, over time they start getting silted up, sediment coming from the surrounding area, evaporation. This lake is probably not really getting much water anymore. So it begins to dry up. And here we see some examples of previous oxbow lakes. Let's look at a picture here. In this photograph, we see an oxbow lake that's recently been cut off and still a little bit connected to the main course of the river. We see some other ones that are further along and they are now disconnected from the river, and some that are filling up already and becoming on their way to becoming what's called an oxbow scar or a meander scar, which once it dries up, it's just like a depression that's left in the landscape. Okay, moving on to drainage basins. A drainage basin, think of them as a type of bowl. Another name for drainage basins are catchment basins, because basically what they do is they catch all the water that falls within a certain area. So as I said, here we have two, so think of them as like two bowls next to one another, and then we have this red dashed line that's called the drainage divide. That would be like the rim of the bowl, so the highest point. But once you fall within the rim, then you have no option, and the water starts going all towards the center, right, towards the bottom of the bowl. And they join up. This is called the dendritic drainage pattern. So the streams have this branch-like, little streams join up to make bigger streams, eventually coming down to the main stem of the main stream running down this drainage basin. So all the water that falls within this drainage divide will fall into this drainage basin. We have here a drainage device that divides two drainage basins. So all the water that falls on this side will flow into this drainage basin. All the water that flows on this side of the drainage divide will flow into this drainage basin. So we look at the drainage basin of the Mississippi River, the mighty Mississippi River. So here we're looking at the Mississippi River, the whole drainage basin. It's very large. It's, of course, the biggest one in the country, and it takes about 40% of the landmass of the continental United States, and it even expands a little bit into Canada. Anyway, a couple of things to notice: that a drainage basin is made up, a large drainage basin like the Mississippi River drainage basin is made up of smaller ones. So there's the Missouri River, which is the second largest river in the US, but it's part of the Mississippi River basin because it eventually flows into it. Ohio River, Arkansas. So we have all these other drainage basins that are smaller and make up the bigger one. And notice that the Missouri River drainage basin, it also has smaller drainage basins. We call this nested, right? Nested drainage basins. There's the Yellowstone River, and then here's a blow up of that. Notice too that the Yellowstone River is born in the Rocky Mountains high up. Remember that the drainage basin is divided or has drainage divides that are like the rim of a bowl or high area. So this is the Rocky Mountains. That would be the highland or high area on this side of the Mississippi River basin, and on this side we have the Appalachian Mountains. So here we have the Yellowstone River coming down from the Rockies and descending down into the Missouri River. Here's another view of the Mississippi River drainage basins. Again, here you can see the nested quality of it. The Mississippi River drainage basin. Here's the Missouri River, which is the second biggest river. But that's made up of the Platte River. Here's the Platte River, which is, inside it has the North Platte River and the Laramie River, ever smaller and smaller. So again, nested drainage basins. Also notice the black line here. That's the continental divide. Any water that falls on this side of the continental divide, like the Colorado River, will flow into the Pacific Ocean. Water that flows on this side will go into the Mississippi River basin, or it will flow eventually into the Gulf of Mexico. Notice here, let me just go back a little bit. Here we have the whole Mississippi River, of course, flows into the Mississippi River Delta. When the river reaches that, it slows down, and as it slows down, it loses energy and it spreads out its sediment. This is over time. The sediment has been spreading out, and here we have what we call distributaries or branches. The river has branched out and deposited its sediment because it now has come into a large body of water, which of course is the Gulf of Mexico.